All right, and here is video number 7, periodic trends ordering. How to order the periodic trends, increasing to decreasing and vice versa. So the most important thing you need to understand is number 1, what is the trend and what is it asking you to do? So notice I have all 4 of our trends on the side, and I'm saying to increase, increase, decrease, and that last one says to decrease. Okay, the other important thing is you have to have a periodic table. If you don't have a periodic table in front of you, you really can't do this. Okay, so I've written 4 elements down. Those are the elements that we're going to put into order based on what we see on the periodic table and the trends. So what we would have done had we been in class is we would have made it into a game. This way I'm just going to show you a real quick way to do this so that you don't get lost, because that's the most important thing is you start to almost second guess yourself as to what you're doing. So the elements that we're going to be working with are CS, W, HG, and RN. And notice I made this one easy. They're all in the same period, which means that it's really pretty easy. You just have to read the trend. There are always a couple of exceptions, and the first exception, I put it into the very first one. Unlike your math classes, they give you the easiest stuff and then they make you guys do homework with the hard stuff. In this case, I started kind of hard from the beginning. So if you'll notice, it says electronegativity is going to be increasing. So you want to put these guys in order of increasing electronegativity. Well, so give it a shot, but I'm going to tell you right now, if you look at your little chart and we look for our marker elements, the fluorine and the francium, okay, we know that if it's closest to francium, it's going to have the greatest electron affinity or negativity, which means that it's going to be the biggest or greatest on the periodic table. Remember, noble gases don't count, okay, because they do not want to attract an electron. They are perfect the way they are. So with that being said, if you were to put these in increasing order of electronegativity, I hope you noticed that I already tried to trick you. If you didn't, let me verify. Okay, if you were to put these in increasing order, CS, HG, R to N, and W, which one will go first? If you said CS, you're wrong. It has to be RN. RN has 0 electronegativity because it doesn't want an electron. So your first element written down here should be Rn. So I'm going to write that now. Rn is going to be our first electronegative 0 electron, okay, or atom. After that, now in increasing order, it should be whatever you have on your periodic table. So then it would be CS, then it would be W, and then it would be Hg. So Rn is the smallest, and then CS is greater, W is greater, and Hg is the greatest. You could have also put commas. I just, for some reason, that's how I do it. All right, so now let's flip the tables and do atomic radius in increasing order. So remember, atomic radius is exactly the opposite. Atomic radius, you get bigger as you go to the left and down, where francium is the largest element. So if that's the case, this is super easy. All you're doing is reading your elements from right to left, and that is your increasing order. And in this case, your noble gases still count because they don't have an issue with being close to one another. They just don't bond with something else. So if I put these back in order on our thing, it should be Rn, Hg, W, and CS. So that should be our order. So our order will be Rn, which is then smallest, then Hg, and then W, and then CS. So with CS having the greatest, and that should make sense since CS is right next to francium. All right, now here's the cool thing. Once you've done one, you pretty much, with the exception of little silly things like Rn being a noble gas, most of it is almost repeatable. For example, ionization energy. Remember, ionization energy is basically the exact same thing as electronegativity. The only difference now, unfortunately, is that your noble gas is included in this, which means that our noble gas should have the greatest ionization energy. So if that's the case, then instead of radon being at the beginning here, meaning it was the lowest, it should be flipped. And it should be on this side being the greatest, which means then all you have to do is go from CS all the way to RN. So we would write this one, CS, W, HG, and RN. Now, the last one is a trick question. And I'm going to give you a second to see if you can figure out why ionic radius is a trick question based on the elements that we have. All right, so why is it a trick question? If you said because there are no ions in our list, you are absolutely correct. Because there are no ions on our list, this is not an answer that we can do. Okay, so ionic radius is not a possibility. So Na. There are no ionic radii in this problem set. There are a few that I've added on Classroom so that you can go ahead and try a few on your own. I'm going to do one more here with you that's going to actually include a set of ionic radii just so you can see what it would look like. But other than that, if you want any more practice, you should be going on to Classroom, and then there's a few there where you can practice and they'll give you the answers to check it. And a few of them even have better videos than what I'm doing, obviously. Okay, I've erased all the rest of that stuff, and we're going to start over with something new. Okay, so we're going to get rid of all of these atoms, since none of them have ions. Let's just focus on ionic radius, okay? So if we focus on just ionic radius, let's try the following atoms and see what we come up with. Okay, so I'm going to say, how about we just focus on magnesium with a +2 charge, calcium, and calcium with a +2 charge. Okay, so let's just focus on these atoms to see if we can put them in decreasing order for ionic radius. All right, so the first thing we need to do is notice that, of course, we actually do have ions now, which means that we can do this problem. And not only if we have atoms can we do this problem, we now need to look into another thing when we look at these, which is not only do we have to know where they are on the periodic table, we also have to know how many electrons they have. And with that being said, your handy-dandy periodic table, you're going to look and see what Mg is. So Mg normally has 12 electrons. And remember, charges means you've lost or gained electrons. So in this case, if you normally have 12, 12 plus 2 really means -2, so you have 10 electrons. Okay, calcium, neutral calcium, is number 20, which means we have 20 electrons. And then calcium with a +2 means we have 20 minus 2 equals 18 electrons. All right, so now if you were to put these in order, decreasing order, that means that, of course, the first one, which is the biggest, is going to be calcium with 20 electrons. So this is number 1. Then the next bigger is going to be our calcium with 18, or sorry, smaller, next smaller. I know what I'm doing, really I do. And then magnesium with a +2 is our third in the order of going from biggest to smallest. So if we were to write these, it would look like Ca, and you can put commas, then you would go to Ca with a +2, and then you would put Mg with a +2. So that's your answer for putting them in order of decreasing atomic radius. Ionic radius. Okay, so let's try one last example where everything is what we call isoelectric. Okay, and I'll explain what that means. But more importantly, let's get rid of some of this stuff, and I'm going to give myself a little bit more room. We'll still do ionization energy getting smaller, but what we will make sure that we understand is what we're even doing in the first place. Okay, so this is going to again be ionic radius. Okay, and it is going to decrease. And the atoms that we're going to use this time are going to be S with a -2, Cl with a -1, K with a +1, and Ca with a +2. Now, isoelectric. Isoelectric is this. Isoelectric means that all of these atoms, or ions, really, have the same number of electrons. And believe it or not, we're going to check that out really quick. So S to the -2, if you look at S of the periodic table, S is number 16. Chlorine is number 17. Potassium is number 19, and calcium is number 20. So they're technically going up by atomic number, right? Okay, but if you have a -2, that gives you then 18 electrons. 17 plus 1 is 18. K minus 1 equals 18. And 20 minus 2 is 18. Notice they all have 18 electrons. So if you have 18 electrons for all of these, same number of electrons, you clearly can't use your number of electrons to help you figure out the size of your ions. So because of that, we then defer back to, believe it or not, drum roll please, atomic radius. Which means this. As your size decreases, your atomic number increases, right? That was just like what we learned earlier. And in all honesty, it works the same. I'm trying to find my paper, guys. Sorry. Okay. It's the same concept as we were saying before. Atomic radius and ionic radius have the same concepts and the same trends. And because of that, when we talk about gaining and losing electrons, in this case, they all are the same electrons. And believe it or not, every single one of these is argon. Okay, so every one of these atoms actually will look just like argon. So you can't just say they're all argon, so they're all the same size, so that there is no decrease or increase in radius. No, there really is. It's just now we go back to, as the size increases, the atomic number decreases and vice versa. So in this case, as the size decreases, the atomic number increases. So we're looking to put them in order of decreasing atomic number. So which would mean, if we were looking at these as atomic number, that's the initial number that we started with. So we would put this as Ca with a +2 is the smallest. K plus 1 is a little bit larger. Cl minus 1 and S with a -2 is the largest radius for ionic purposes. Okay, so CS is my largest ionic radius. Because remember, you're talking about all of them having the same number of electrons. So if they all have the same number of electrons, you now have to defer back to, as the size decreases, your atomic number increases. All right, so I know it's confusing. And like I said, I tried to save this one till last. That's it. If you need more help, check out the examples I gave on Classroom. Okay, talk to you guys later. Good luck tomorrow. Bye.